So hello there. Today I would like to share with you a project that I was working on, and basically, it's a web application that allows you to search images using text, image, and audio. So, for example, also your voice. The way it works is that I collected 6K images, or sorry, I took from somebody else a data set of 6K images that were scraped from lexical.art. And if you don't know about it, this is a website where people can just go ahead and upload their stable diffusion generated images. And I took the dataset of 6K images, put them on Activeloop Deep Lake. We can have a look here. Yeah, so this are all the images that we can search for. And I create embeddings using a new model. I mean, I think it's like 6 months old, maybe 4, from Meta, called ImageBind. So, in a nutshell, this is a transformer model who has been trained on multiple modalities pairs. So it means that, yeah, this image. So it means that I have in the data set text connected to images and vice versa, then maybe text connect to audio, and maybe video connected to images, etc., etc. So this model was trained on all these modality pairs, and here you can actually see in gray are the modalities that were actually in the dataset. So like this is image and text, I guess. Here we have audio and video, yeah, it makes sense, etc., etc. But then the model was also able, or at least they claim it was, to learn the mapping between modalities, you know, that were not paired in the data set. So if I have a data set of text, images, and audio and video, then the model was also able to learn a mapping between audio and text. So basically, you can feed to this model a lot of modalities. In our example, audio, text, and images, and you get the same, and you can use the same weight. So compared to clip, in which you need to encode the text with a text encoder and the image with an image encoder, here we use the same model, right? And if we go ahead and have a look at the code, I can show you how it's done. So let me show you my code in Visual Studio Code. Let me make it a little bit bigger. So basically I have a script here. It's called create embedding.py. Here I'm reading the images, the dataset from lexical.art, and I'm going to create embeddings. And later on, I will use the embeddings. I will store the embeddings to the vector DB. So basically here we have a couple of functions that I've defined. It's very easy. You just need to go on GitHub and get the ImageBind Git repo and install the requirements, and then you can basically load the model. So in this case, I'm directly called ImageBind huge, and you need to pass a dictionary. If I want to get text embeddings, I need to prepare my input as a dictionary. So I need to say, hey, you know, this is going to hold the text, and I need to load and transform with the right loader. Again, this is taken from the original GitHub implementation, which is also in my repo here, because I just changed a couple of things just to make my life a little bit easier. Yeah, I also have a blog post, by the way, which is gonna be live on Activeloop, but you can also find that on GitHub. And here I go a little bit more like step by step about that. But now in the video, I want to get you an overview, and also we want to have a look some live demo, right? So yeah, so basically I created some embeddings, you know, just store as normal pickle files, and then basically I can load my embeddings in Activeloop. So then we can search. So I have apologies. I have my vector storage class here, which is just handy class that will make my life easier to interact with DeepLake. And DeepLake is a vector DB from Activeloop that we're going to use today. It's quite straightforward to store stuff there, to be honest. You just need to initialize a dataset. In this case, I'm doing DB engine true. It means that I'm not going to run it on my computer, but on their servers. And then basically I need to tell DeepLake the shape and what I would like to store. Similar to create an index in other types of database. So here, I'm going to say, hey, I want a tensor. It's called metadata. It's going to be JSON. So so it's going to be the metadata for each of my image. Then I would like to have an image. And then I would like to have my actually embedding. So this is the important one. So embeddings is going to be of type embedding. It's going to be a floor 32. And then basically I just call my class with an help function called add-torch embeddings, which is loading my embeddings. In my embeddings, I already stored the metadata. Now I need to fetch it and store to DeepLake, and then I just do ds.append with a dictionary, and the keys have to match the names that I gave to the tensor, and then I add my stuff here. So this it needs to be an NumPy array. Here you can see to CPU, to float, and NumPy. Yeah, and basically as soon as you do this, you end up with this dataset view, right? And if I click on an image, I can actually see the data. So this is my metadata, and here I'm just storing the path. Yeah, so basically, you just need to get some embeddings using this model, and then you can search using text, other images, and audio, just creating the embedding from the same weight, from the same model. So I have this web application made in Gradio. If I search for a cat, I'm gonna find some cats, right? I can also, just use an image here. I can use, so let's see what we have. I have some data. Just realized, yeah, there we go. So this is the demo. Yeah, so if I search for a cat, so let me show that to you. It's gonna take a little bit. It's not gonna take a little bit because the model is slow. It's not because I need to fetch all the image from an S3 bucket, so that maybe it's gonna take a little while. We need to fetch all the 15 images, and here we can see we have some cat image in the database. I mean, this is not really exciting, right? It's just normal way to search. So let me also use a dog image. Yeah, so let me actually go yeah, data, test, and dog image. Yep. So we can also search for a dog, right? Let's wait a second. A second. Yeah, and we have some some weird looking dogs here. Okay. Yeah, and remember, different modalities, so text, images, same models. Now I can also use an audio. I have an audio of a cat, so we're gonna try that. Yeah, we have a cat here. Let me play that for you. Let's see, like, to me, I'm not a cat person, so it doesn't really sound like a cat, but we can go ahead and search that. And let's give it a second. Okay. Yeah, it makes sense because it didn't really sound like a real cat. It sounded a little bit more like, yeah, some sort of bird. Yeah. Okay, now, so remember, we're using the same way to compute all the modalities here. So if I have multiple inputs, I can just sum them, and we'll basically get an embedding, which is like the summation of the input. In the paper, they show a couple of examples. So let me show you. Apologies. Let me show you the image from the paper. Yeah. So here, if you get some image of fruit, you add the sound of birds, then you will retrieve image, you know, with fruits like in the outdoor, right? And here we have, I don't know, and some claps. So now this is a wedding. Similar, a clock, charge bells, and then we get, you know, a charge with a clock. In my experiments, we will have a look now in a second. This doesn't really work so well. Like in my experiments, when you use text plus something else, like text plus image or plus audio, the text is just so strong, and the way that, you know, it's implemented in the code is so it's so simple. Basically, yeah, I get all my embeddings from the text, image, and the audio. I stack them, and then I sum them. GG. That's all it took. Yes, so let's have a look. I have a sound of a gun. We can add this. Okay. And what if I say a person? So now we're going to embed the text a person, the audio of a gun, and we are going to sum them up. So I know in the data set, like, there are also images of soldiers. So this is what I'm going to expect, to be honest. So let's have a look here. Here I can see something. Soldier. Yeah, I mean, so let's try to remove the audio of the gun. Let's try just to search for a person. Yeah, I mean, we can actually see that somehow it changed a little bit the order now. So let's try to have an image of a car. So let me go, yeah, and then I think I need to go, oops, here, and here we have a car, right? This is just a boring Tesla. Let's see if we can find more cars. And then I also have an audio of a very fast car, or a sport car. So I will let you to use that to see if we are able to interesting. We got interesting. We got quite a few unexpected things. Like we got Pikachu. Yeah, but I'm looking at the scoring now, like the actual cosine similarity, and it's quite high. It's quite high. So it means that, you know, this image is not really great, right? It looks, I mean, it looks like kind of low resolution. So let's try to add the F1 sound. This is a sport car now. So I'm thinking if I am adding them, you know, I should basically get, you know, fast looking cars. Yeah, it works. So here we have a fast looking car, a pilot of a fast looking car, etc, etc. And here we have I have no idea what this is, honestly. Okay, so let's continue. I have the audio forest rain. Okay, so let's try to just use this and see what we're going to find. Okay, we have, yeah, we have something with forest. Yeah, some rain here. Yeah, so what if I use I don't know, I also have sorry, damn, I also have data test a bear image. maybe, I don't know if there are bears in the dataset, we will look, but my gut feeling is that we should get animals in the forest with this combination, right? Very similar to before, very similar to before. Something has actually changed. We got animal here in the, yeah, some water. Yeah. Let me actually remove this. Let's say city. So now I would like to have images where there is rain in a city. I'm gonna say a city. I mean here, yeah. Here I can tell that the text is really strong, right? So here we can actually see we don't have anything connected to rain, right? But if I input an animal, let's see if we get something connected to, you know, to this sound. And this is recurrent. In my experiments, every time I start using text plus other modalities, the text is just, you know, really strong. Yeah, for sure here, we're not using the rain, right? Because if I remove the rain and the search, it's very similar. It's very similar. Let's now actually try the microphone. So let me, I don't know, just look on Spotify for, so I don't know. So let me, or I can just try to bark. Woof, 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 woof. Okay, looks like I having some technical issues here. Let me try to refresh this. Woof, 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 woof. Okay, apparently the microphone is not working. This is interesting. Was working before. Maybe I changed something. I don't know. But we can actually. So let me see. Let me see if we can find out something. Yeah, something else to look. It looks like also the web page actually stopped working. Let's refresh this. Let's have a look at the data here. Okay, I can see we have some cyberpunk things. Yeah. I don't know. I kind of find something that we can try to search upon with some tag. Sorry, with some audio, and maybe. So let's actually try picture of flowers then, right? Let's try flowers. Images. Actually, yeah, this should work. Save image. Yeah, we'll save it there. Let's also try that. Let's see how it's going to, yeah, what we were going to find. Ah. Makes sense. Actually, these are beautiful images. So let's now try to re-add the forest rain. Let's see. as you can see here, the embedding addiction that they were showing on the paper is not really working well. So my take here is that all these examples are cherry pick, 100% cherry pick. In reality, it's not working. So it's working sometimes, but not how you would expect. Okay, so yeah, I mean, I hope you're enjoying the project. All the code is here on GitHub. I'm gonna place the link to the repo on the description, and the blog post you can find it here in blog, but it's gonna be hosted on Activeloop as well, and yeah, and I'm planning to somehow host a demo somewhere, but I need to have a machine with a GPU. So if you see this as a to-do, at some point I will host it. I'm gonna try to do it before I release the video, but I need to understand, like, you know, where to host it, which is not so straightforward because, you know, I need to pay for a GPU. Yeah, so I really hope. And last thing, you can actually explore the data set. I'm gonna place a link to this as well, and this exploration tab is actually, it's nice. This data set is really cool because, you know, it just contains a lot of cool image, right? That people have generated. Like here we also see some sort of frog in the army. Well, I hope you enjoyed. I'm gonna see you on the next one. Bye.